This is Jenny Kunkel, and in this video we're going to pick up where we left off in the first video on physical design, and in the second video we're going to start by adding an index. We're going to assume that somebody wants to search on the teacher's name, and we're going to create an index on the teacher name field in each of the SQL Server and Oracle tables using the named index. So let's go ahead and let's switch to SQL Server first. We're going to place it right after the sequence creation, and I'm going to go ahead and copy it in. Once I have it copied in, I'm going to go ahead and execute it. And I also want to add the drop of our sequence. I forgot to put that in. The sequence is not tied to any table per se, so we can drop it at any point, but for our index, it's tied to the table, so I need to put that before I would go ahead and try to drop any of the actual tables themselves. Then I'm going to go ahead and switch over to Oracle and pretty much do the same thing. I'm going to copy in the index creation statement, paste it in after the sequence, run it, and then come in to the top and put in my drop of my sequence. And again, I'm going to place my drop for my index above the tables, so that everything would be tidy if I would try to rerun the script. Now switching back to the slides and advancing, we have how we can remove our table, our index, sequence, and constraints. We've looked at the table already. We've dropped several of them. We have the ability to drop our indexes. In the case of Oracle, we do not have to specify the table that that index is on, but for SQL Server, we do have to specify the table that the index is on when we go and drop that index. We can drop the sequence. We've seen how that works. And if we need to drop the constraint, we just need to drop the constraint with the constraint's name. For our physical design, there's a lot of times that after we create our initial tables, they're in production, we need to go ahead and make changes to them. We may need to go through and add a column. We may need to drop a column. We may need to change how long a column is. Might start out at 50 varchar, and we found that we need to enlarge the column to be like 75. We can make those changes. We can also add some additional check constraints. Typically that's where we change something from a null to not null, and that's what happens most frequently. With our Oracle definitions, we have a little bit more flexibility with altering the table, where we have to use stored packages that we'll look at later with SQL Server to change column names or to change the name of the table. We can do that with an alter command within Oracle. If we need to alter the table, we can add, we can modify an existing column, we can drop the column, or we can add a constraint. So it's a little bit more simplified format. There's a few more specific options that we have to use with SQL Server. We'll take a look at some of those. If a table already exists in production and we want to add a column to it, we can go ahead and use the alter statement and essentially say alter table, give the table name, and then specify that we want to add, and then we're going to specify the field and then the individual characteristics of that field that we want to add to the table. It could be that we want to add it with a certain data type with a certain length, and we want to make it not null. Then we would go ahead and do that, or we could set some type of a default. If it was a date field, maybe we want to set it where the default is the sys date for Oracle, or we want to set it with a default of the getDate function. For SQL Server, we can do things like that as well. But in our case, we're just going to go ahead and alter and add the student email. We're going to assume that this is something that we determine later, so we're going to put it at the end of our script. We're going to start with SQL Server first, and scrolling down, going to put it at the end, and then execute that. Once I go ahead and execute that, we should be able to refresh the table, and if we look at that student columns there, now we see that we have that student email field that has been added. We're going to switch over to Oracle and do the very exact same thing. We're going to come down to the very bottom and we're going to add that email field as well. Going to execute that, and then if I refresh the students, I should be able to do that with an F5. We see that we have the student email there as well now. Not only can we add a column, we can also change a column size if we have a new requirement that we are going to have course names that are going to exceed 50 characters. We can change it to be something like 100. In the case of SQL Server, not only do we alter the table, but we alter the column. In Oracle, we alter the table and modify the column. Let's go ahead and switch and execute this in SQL Server. We're going to change that. Pasting in the command and running it should show us that we have a length of 100 after we refresh it. Currently we're showing 50. If I go ahead and hit F5 and expand the columns, now we see that we are at 100. Now if I go over to Oracle and I look at my course, I can see that I have it currently at 50. I'm going to change that to 100, copy in the statement after the alter statement there, and if I run this, I'm going to go ahead and close this window, and if I reopen it, it's now showing me that I have 100. Now going back to the slide, we also have the ability to change a column to not null. So if it's nullable and it starts out that we do not require some data to be entered before saving a record to the table, and then we decide that we really want the data to be entered and we're going to require it, we can change our definition on a column to be not null. This is something that happens a lot of time in production where we start out one way and then we change mid-course, and we have a couple different requirements that are prerequisites to actually making this work. The first thing is all the data that's in that column has to have a value. If we don't have a value, we need to go set some type of a default value. Null is not going to work any longer. We also need to, in some cases, either drop or disable constraints or indexes that we may have on a column. So we need to understand all of the constraints that are set up for our particular column. For Oracle, we can go ahead and do a select asterisk from all constraints and specify the table name, and it's going to give us back the list of constraints from that query. For SQL Server, we have to execute a stored procedure that's going to give us a little report back that shows us what constraints we have on the table. Now, if we try to drop something and we have constraints on the table, that's going to be problematic. And we will need to potentially either drop in the case of SQL Server or disable in the case of Oracle those constraints before we can actually get things to work. And we'll take a look at that with trying to set our teacher email, which is currently nullable, to not null. If we execute it just outright, it's going to give us an exception, and we can take a look at that. But we're going to first execute the select statement or the help statement from SQL Server and then Oracle. And in this case, we're going to go ahead and start with SQL Server, and this is going to be where we execute the stored procedure. And to execute a stored procedure, you use the execute or exec for short. You specify the stored procedure name, and then it's going to have a parameter list. In this case, it requires the table name to be passed in as the parameter, or essentially an object name. It's going to give us all of the constraints, and we can see that we have a primary key, but it's on the teacher ID. It's not on our teacher email. The concerning one is going to be the unique constraint that is actually on the field that we want to set that null constraint on, and that's going to be problematic. If we would go ahead and try to alter that at this point, and if I bring it over and execute it, we can see that it's going to fail. So if I execute this command, it's going to give me a lovely error that tells me that I have a problem with that unique constraint, and I need to be able to drop the constraint before I can actually have this work. So this is going to be essentially where I need to provide a drop constraint before my alter statement, and then once I have completed the altering of that field, I want to go ahead and then add back my constraint so that I don't have anybody trying to sneak in data that's not unique. So at this point, I'm going to go ahead and run the series of commands here, and notice that it is now completing successfully. If we would go ahead and take a look at our teacher table and expand our teacher email, you can see that that is now not null and everything has been changed there. We can go ahead and on the Oracle side execute that query, and that query is essentially going to check to see from the all constraints, which is a view that's provided. If we execute this, it's going to give me all the different constraint names. Now these are lovely, aren't they? So those are some of the system generated names that really don't give you any information about what they are. Whereas if you see the PK and the UQ, you can understand essentially what they are before having to look at the combination of the teacher ID is not null, the teacher name. So those are not null constraints that it generated for us. But we can see that we have the unique teacher's email constraint and we have the primary key as well. So essentially the same type of information that we saw from SQL Server, but not showing us our foreign key associations. In order to modify and change that to a not null, we need to go ahead and disable the constraint. Then we can modify the actual definition to change it to not null, and that's going to require us to give it the field definition regardless of the fact that we don't want to change that. And then we can go ahead and re-enable that constraint. So I'm going to go ahead and paste in what we need to do here. So that's going to be where we're going to disable our constraint on that unique index constraint. And then we're going to modify our teacher email and change it to not null. And then we're going to go ahead and enable that constraint again. So if we execute this, it's going to succeed. And if we go ahead and expand our teachers, we should now see that it is not nullable, showing us in that column. Now if we go back to our slide deck, pretty much showing us for SQL Server the order of statements that we needed to execute, and then for Oracle as well what we needed to execute. With renaming a column, and I'm not necessarily going to go through and rename columns, but we can go ahead and do the execution of the stored procedure SP rename, and in this case we're going to give it the table name dot the field name, and then this is going to be what field we want it to be renamed to, and then we're indicating that it's going to be a column. If we give it all that, it's going to go ahead and rename that column for us. Much easier on the Oracle side. We just basically tell it to alter the table and rename the column from this to this. That's a little bit more clear and concise in my mind. At least you know what you're doing there. If we decide that we want to rename a table, we can use that SP rename and just basically give it the table name and then the name of the table that you want to rename it to. And then if it's Oracle, then we're just going to alter the table and rename it to whatever the table name is. Now the caveat here is if there are views or foreign keys that reference the table being renamed, or any check constraints or triggers on the table, attempts to rename it will generate an error, which means that you would have to go through and drop the constraints, drop the triggers, drop everything that you would need to before you could actually do that renaming, and then you would have to reapply it after making essentially some changes to make sure that you have the foreign keys and the triggers and everything pointing to the new table name. So that is all the material that we have for this. In the next video, we're going to take a look at going from a logical to a physical design on a second problem.